Good afternoon and happy St. Patrick's Day. I'm Irish myself, not as much as Scott is, but I do have some Irish in me, and I've been to Ireland 3 times. It is my absolute favorite country that I've ever visited, and I could honestly live there. To be honest, I not filled out, I looked for teacher exchanges, but at the time when I was getting my credential in the first few years I had it, they didn't have any teacher exchanges, so super bummed about that, but oh my gosh. Anybody out there who watches this, if you have a chance to go to Ireland, go. It'll be an amazing trip. I've seen some of the places 3 times. Sometimes some places I've only seen once, but I can't even come up with anything that I don't like about any of those trips that I've done. They're amazing. Ireland is absolutely amazing. So happy St. Patrick's Day. Yay, I wish I had my Ireland flag to wave. Anyway, we are getting going on our solving quadratics chapter. It's chapter 9. The previous day we did section 7.5, and that was solving quadratics by factoring. And I did that one ahead of this one for a reason. Today we're going to be doing solving quadratics by graphing. And I know my kids are probably like, ugh, more graphing, because they just had a whole chapter on doing nothing but graphing and quadratics. But the way that I solve quadratics by graphing is I factor it. There's no real need to find the axis of symmetry. There's no need to go through that whole process of finding your 5 values of x to get your y. And so I've always just done it by graphing. And so my kids will be able to understand why I did the solve by factoring yesterday instead of this one. So let's get going. Example 1. Solve by graphing. Which, when I was in a different textbook, all the solve by graphing, it wasn't even called solve by graphing. It was called just solve by factoring. And then they would graph it. So they go hand in hand. So here we go. We are going to solve x squared plus 2x minus 3 equals 0. And we're going to do it by graphing. Graphing. So remember, what you're looking for when you solve a quadratic are your x-intercepts, your roots, your zeros, your real roots, your x-intercepts. I think I just said that one. Your roots of the equation, your zeros of the function. And when you do that, you need to find where the parabola is crossing the x-axis. So I do this by factoring. I don't have to go through this whole process of finding, negative b over 2a, get that, plug that in to find y. You don't have to do that. So we're going to factor this. So here we go. And I factor this guy by the ninja star. So negative 3 is on top. Positive 2 is on the bottom. X and X here. Technically, this top is A times C. So negative 3 times 1 is your negative 3. B is on the bottom too. AX and AX are here. Since A is 1, I just put X. And these guys, remember, are your factors of negative 3 that add up to 2. So sign patterns. Since C is negative and B is positive, that means one of your factors is positive. That means one of them is negative. And the only pair of factors are 3 and 1. I put the numbers in, then I figure out what my signs are. So we have positive 2, but one of these has to be negative. Whoops, put the negative on the wrong side. Okay, here's your binomials. So then we have x plus 3 and x minus 1 equals 0. So I went from my quadratic equation into factored form. And now we use our zero product property to solve for our x's. So really, this is just a huge recap on yesterday with a little bit of change here. So set both A, here's B. Set them both to 0 to solve for x. So subtract 3. So x equals negative 3. That's one root. Add 1. X equals 1. That's your other root. So what that looks like on a graph, since we're not going through the whole process, all you need to know is how to kind of sketch it. Because you don't necessarily need that vertex. You don't necessarily need that axis of symmetry. So if our parabola is crossing at negative 3 and 1, we have our x-intercepts. And if you want to sketch a graph, I would look at A. Okay, A is positive, so it's going to open up. and a is also 1, so it's going to be the same width of this parent function. And then I just kind of sketch a u. Let's see how close I was. Oh my gosh, I was almost spot on. The vertex is actually -1, -4. Oh my gosh, look at that. Just by sketching. Okay. So remember, what you're solving for are these guys. Your x-intercepts. And we did it through factoring, and then we sketched a graph. So we could see our parabolas crossing at -3 and 1. So our answer, our solutions, are x equals -3 and x equals 1. This quadratic equation has 2 zeros, 2 roots, 2 solutions, 2 x-intercepts. They are -3 and 1. Not too bad, huh? All right, now example 2, still solved by graphing. We're going to do a different type of equation. Example 2, solved by graphing. I haven't done a lesson for my bedroom in a while. Normally I'm downstairs. All right, here we go. X squared minus 8x equals -16. Okay, first thing we want to do, we want to make sure that our equation says ax squared plus bx plus c equals 0. This does not. That does. Right way. So we need to get this -16 on the other side. And we're just going to add it. Because you want to get it to 0 out here. So x squared minus 8x plus 16 equals 0. There we go. Now we want to factor. There is going to come a time where we want this guy over here, but that's coming later. I think that's next week. Yeah. Okay, let's factor this guy. So 8 times c at the top is 16. B is at the bottom, -8. ax and ax, which in this case is just x. If there was a 2 here, you'd put 2x and 2x. And then there's something else for that as well. All right, factors of 16 that add up to -8. C is positive. B is negative. That tells you that both these factors are negative. So factors of 16, 1 and 16, that's not going to get you anywhere near -8. 2 and 8, no matter what we do with those signs, we're not going to get -8. And 4 and 4. 4 and 4, that could get a 0. -4, -4, -8. +4, +4, +8. So yes, it is actually -4 and -4. I think I did one of these with you guys yesterday, my kids. So we have the quantity x minus 4 squared equals 0. But then you may be thinking, wait a minute here. The zero product property says a times b has to equal 0. I don't see an a and I don't see a b. I just see one binomial. Remember, the square of a binomial, this is just the simplified version. It's actually the quantity x minus 4 times the quantity x minus 4 equals 0. So now you actually have a and b that equals 0. And you start solving them. Hopefully by now you've caught on that they're the same binomial. So, we could just solve one of them. But if you want to, you could solve x minus 4 equals 0 over here. Add 4 to both sides. I got x equals 4. So this one's a little bit different than the last problem. The last problem we actually had 2 different roots. This one will only have 1. And so if this is where the parabola is crossing the x-axis, well, let's just kind of sketch that. And I just did a quick 4 all the way around. Well, we just have 1. And if you're thinking about graphing vertex form, that's a good call. Remember, you have the square of a binomial. It's x minus k, then plus h, hij, 8, no, 8, x. It's so weird looking at this backwards, it throws me off. X minus h, and then k's on the outside, and h and k are your vertex. So your vertex is actually 4, 0, which we have right here. Well, if that's your vertex, and that's your highest or lowest point, that tells you that this parabola is only touching the x-axis. It doesn't actually cross it, it just touches it. Just touches it. And so if I want to sketch a graph, A is positive, so it's going to open up, and it's just going to touch here because this is the vertex. I probably do that a little bit thinner just because I don't have much room over here. So that would be your graph. Is it a sketch? Yes. Is it exact? No. So this parabola is just touching the x-axis. So when you have one root, the parabola touches the x-axis and it is the vertex, which means that's also going to be, in the vertex, you're going to have your axis of symmetry. So this is the part right here, this little imaginary line that divides that parabola in half. All kinds of things are starting to come together. Click, 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 click. All right. One root, parabola touches. Two roots, parabola crosses. So I wonder what we're doing for example 3. I'm sure some of my kids could have figured this out by now. And those of you guys who are out in YouTube land, you could probably figure it out. Well, I had parabola crossing, parabola touching, two roots, one root. What happens? Can you not have a solution? And if you guess that's where we're going, you're correct. Example 3, solved by graphing. Still, same directions. So, we have, what's my equation? Negative x squared equals 4x plus 5. And again, this is not written in the form ax squared plus bx plus c equals 0. So you need to make it equal 0 first. You have a couple different options. You can either add x squared to both sides, or you can subtract 4x over here and subtract 5 over here. It's your choice, but to be honest, when I have to move things, I move the fewest amount of terms. So I'm going to add x squared to both sides. And then I'm just going to kind of put it over here, somewhere where I'm not showing underneath one of these terms, because you can't combine these. They're not like terms, so that's why I kind of put it off to the side. Knowing that right now I have 0 over here equals, now I'm going to put it in standard form. I'm going to go x squared plus 4x plus 5. And we're ready to go. Should we freak out because it's written backwards? It's the same thing as if I put this equals 0 back here. It doesn't matter. So we're going to factor. Here we go. Okay, 5 up top, 4 at the bottom, x and x. Sign patterns. C is positive and B is positive, so that tells you both of these factors are positive. Okay, the only factors of 5 that we have are 5 and 1. So let's figure this out. All right. Well, 5 times 1 is 5. Cool. 5 plus 1 is 6. That's not 4. All right. In order to make this 4, I could go, ooh, that would work. That would get me B for 4, right? Because 5 minus 1 is 4. But you got to remember, 5 times negative 1 does not equal 5. Okay. So then I'm going to start playing with my signs. Negative 5 times 1. That's not 5. Negative 5 times 1 is still not 4. It's a negative 4. Negative, negative. Negative 5 times negative 1, that's a positive 5. We're good there. But remember, negative 5 plus a negative 1 is a negative 6. So, we've run out of options. What this tells you is this guy cannot be factored. So the polynomial x squared plus 4x plus 5 cannot be factored, but that doesn't mean you can't solve it. That's where this chapter is going, because there's going to be sometimes you can factor, sometimes you can't. Sometimes you feel like a nut, sometimes you don't. I have no idea why I just said that. So, this polynomial cannot be factored. So what does that mean for your answers? Well, that tells you that this equation has no x-intercepts. No x-intercepts. No roots. However you guys want to say this, no zeros. So what does that mean? In my kids, I told you I was going to ask you a million times this chapter, which is, I know, a slight exaggeration. Well, all these things are where the parabola crosses the x-axis. But if it can't be factored, and you don't have any x-intercepts, you don't have any roots, you don't have any zeros, your parabola does not cross the x-axis. But that doesn't mean you can't solve it. That's what's coming. Different methods on how to solve this guy. Just means you can't solve it by factoring. That's all. So what would that graph look like? Well, I'm going to give you a couple examples. And I'm not even going to try it and sketch. I'm just going to give you some examples. Yeah, very rough hand-drawn coordinate plane. That could be a parabola. It doesn't cross. This would be no solutions. That's another one. That's not crossing the x-axis. You're going to get into algebra 2 when your graphs go this way. That'll be fun. That's x equals something. Y squared. So these are examples of parabolas. Don't look at this one. Maybe I shouldn't have shown you that one. Which is kind of fun to see where the stuff goes. These would be examples of parabolas, of graphs, that cannot be solved because they are not crossing the x-axis. So example 3. There are no roots. There are no zeros. So any one of these is your answer. And you don't want to put 0 because 0 is a solution. 0 is right there. So just be careful you put no or none. No solutions. Something like that. And if you want to get technical, you can say no real solutions. Not too bad. All right, let's sum these up real quick. What it looks like for solutions. So let's go solutions. Solutions. Here we go. We're going to do 3 little mini coordinate planes. I'm not even going to do the numbers. So this guy. It's crossing the x-axis twice. So that tells you there is 2 roots, 2 zeros, whatever you want to say. 2 roots. 2 x-intercepts. However you want to say this. Okay, remember they all mean the same thing. So an example of an answer would be something like x equals 4, x equals negative 2. Something like that. You'll see 2 answers for solutions of x. So this is where it crosses twice. And now we're going to do touch. It would be negative on this one. So this one, there's 1 root. There's 1 x-intercept. Okay, I'm just going to use root. And so an example of your answers when you solve it would look like x equals 3. Something like that. Okay. And then something like that. That looks kind of like a line. Let me fix that. Make it more curvy. Does it have any roots? Does it have any zeros? Does it have any x-intercepts? No. So I'm going to put 0 roots. Maybe I should put these as stars. I'm just looking at this going, that kind of looks a little weird. 0 roots. And so your answer to this would be something like, no solutions. I ran out of room. No solutions, no real solutions. Something like that. And so, if these are solutions, let's sum this up. It crosses twice, 2 solutions. If it touches, 1 solution. If it doesn't cross or doesn't touch, 0 solutions. That's when you would use 0. If they're asking you for the number of solutions, you would say there's 0 solutions. But to write a solution with an equation like this, you would say no solutions, or no real solutions, or no x-intercepts, something like that. So just be careful. If they're asking you for the amount or for how many solutions they have, then you would use 2, 1, or 0. And you're going to see this again, this chapter coming up. All right. I'm done for the day because we're going to do quadratic word problems after we're all done figuring out how to solve a quadratic. By the way, there are 5 methods. And so once we figure out how to solve everything, then we're going to do some quadratic word problems. A lot of them involve kicking a ball, hitting a ball, or drop kicking your sibling when they're annoying you. Something fun like that. Not that I actually want you to drop kick your sibling, but, it just makes problems more fun when, you have something entertaining in the problem. All right, guys. Be excellent. Be kind. Happy St. Patrick's Day. Well, bye.